This is review 3 over functions part 1. Problem 1 asks us to solve negative 2 parentheses 3x plus 2 plus 4x equals 12. So remember, first thing I have to do is distribute negative 2 to 3x and negative 2 to 2. Everything else stays the same. And when I multiply, negative 2 times 3x is negative 6x. Negative 2 times 2 is negative 4, and then the 4x and the 12 stay the same. To continue solving for x, I'm going to combine my like terms. I have negative 6x's and 4x's. So if I owe $6 but I pay someone $4, I only owe them $2, and everything else stays the same. So negative 2x minus 4 equals 12. From here, I still box my term. Negative 4 is on the outside of that box, so I'm going to add 4 to both sides. I'm adding again, remember, because I need to move it. So 12 plus 4 is 16. And then to close this out, divide both sides by a negative 2. 16 divided by negative 2 is negative 8. For problem 2, they just want me to simplify. Again, with these parentheses, I have to distribute negative 3 to 3x and negative 3 to negative 1. The 4x stays the same. So in green, negative 3 times 3x is negative 9x. Negative 3 times negative 1. Remember, a negative times a negative is a positive. 3 times 1 is 3. 4x stays the same. Remember, we are simplifying here, so we're not solving for x. We're just putting this in the lowest terms possible. I have 4 x's, and I'm taking away 9 of them. So if I have $4, but I owe someone $9, I could give them that 4, and then I still owe them 5. So negative 5x plus 3. My x's and my numbers are different terms. I cannot combine them. Therefore, I cannot simplify any further. Problem 3, Miss Adams bought a refrigerator that costs $1,200 including tax. The cost of electricity is estimated at $78 per year. Write an equation C for the total cost of the refrigerator including electricity over n years. So the total cost is going to equal that one-time fee of the refrigerator plus $78, and then they tell me to use n for years. So C equals $1,200 plus 78 n. Problem 4 asks me to write an inequality from problem 3 to determine how many years it will take for the total cost to be more than $1,600. So where will the cost, so $1,600, where will that be more than $1,600? So we are looking for where the cost is greater than $1,600. This is my cost. So you could say cost is greater than $1,600 and then replace C with $1,200 plus 78 in. Problem 5, if 3x plus 12 equals 48, what's the value of 2x's plus 1? Well, in order to find 2x's plus 1, I first have to find 1x. So I'm going to take this 3x plus 12 equals 48 and solve. Remember, I solve for x by moving 12. In order to move a positive, I subtract it. So 3x equals 36. And then divide both sides by 3. X equals 12. So if 1x equals 12, I'm going to plug this in here because I want 2x's plus 1. So 2 times 12 is 24. 24 plus 1 would be 25. Problem 6, they want me to solve for L. So when I box my term with L, 2w is on the outside. So I'm going to subtract 2w's from both sides, so it cancels on the right side. On the left side, I have p minus 2w. P and w are not the same letters, so I leave it p minus 2w. And then to solve for L, I have 2 times L, so I'm going to divide by 2. On the right side, that cancels. On the left side, I can leave it as P minus 2W divided by 2. Problem 7, a cable company charges $75 for installation and $20 a month. Another company is no installation fee but $35 a month. For how many months of cable service would the total cost be the same? So where will these be equal? These is referring to the first company, $75 one-time fee and $20 a month. And the second company, which is $35 per month. In order to solve, I move the smaller m to the other side using the opposite operation. So positive 20m becomes negative 20m, so it cancels on the left. On the right, I have 15m. And then I divide both sides by 15. So months would equal 5, or 5 equals months. On problem 8, Jessica's having friends over for dinner. She has $18 to spend. She orders a pizza for $12 and drinks are $1.50 each. How many drinks can she order? So if she only has $18 to spend, whatever she spends has to be less than or equal to 18. She's planning on spending $12 and then $1.50 per drink. So $1.50 times D. I subtract 12 from both sides. So 1.5D is less than or equal to 6. And then divide both sides by 1.5. And I get 4. So she can get 4 or less drinks, or up to 4 drinks. Problem 9 asks us to list the ordered pairs. So I'm going to go from left to right so I don't skip any. So this point here is at -5, 0. And then -5, -4. And remember, you can always put out your plus and your minus. Minus is the bottom and the left, plus is the top and the right. So then for this point, I go left 2, so -2 up 1. This is the point, 0, because I don't go anywhere x or y, or don't go anywhere on the x, and then I just go up 6. This point down here, we go to the right 3 and down 4, so 3, -4. And then this point over here, we go to the right 7, up 2. When I create my mapping, I put my x's on the left side. And remember, if a number is repeated, we do not rewrite it. We only write it one time. So for my for my mapping, I'm listing all my x's. And then for the y's, I'm going to list all my y's. Again, if they are repeated, I do not repeat them. The order in which you write them does not matter as long as you do not repeat. So for my mapping, I have to finish this out with my arrows. So with the arrows, I'm saying starting from -5 on the x, -5 goes to 0. It also goes to -4, so I draw 2 arrows from -5. -2 maps to 1. 0 maps to 6. 3 also maps to -4, and 7 maps to 2. My domain is going to be the x's that I wrote in the mapping. And remember, because these are all broken up points, we do the little brace or the squiggly line. And then my range is the set of all y's. So again, I use the brace or the squiggly lines. My domain is just my x's and range is my y's. And I'm just getting these from the mapping because the mapping and domain and range do not repeat. Now this is not a function because when x equals -5, it repeats. Okay, so two different ways. I can see it in the, three ways. I can see it in the ordered pairs. I can see it has two arrows from the mapping. Or I can see that it does not pass the vertical line test. So three different ways in which you could know this is not a function. Problem 12 asks us to identify the domain and range and then classify as discrete or continuous. So remember, domain is x, range is y. It's Dr. XY. So my domain on my x's, the furthest x I could go would be 1, 2, 3, 4, -4. This is going to be an inequality with the line underneath it because it is a filled-in bubble. I put x in the middle, and then when x is a +2, it also has a filled-in bubble, so a line with the inequality. Now my range, again, because I have two full bubbles, I'm going to use the less than or equal to signs.
You need to make it to the office quickly. Graylin Bowman, to the office.
And my lowest y, 1, 2, 3, 4, 5, 6. So I go all the way down here to -6. So bottom to top. Go all the way down to -6. Come all the way up to 1, 2, 3, 4, 5, 6. So my y's take up all of this space. And then my x's take up left to right. Now this would be a continuous graph because the line continues. It is continuous because the line continues. Problem 14, I have one bubble here, so I'm going to have one inequality. This bubble is at the point 9, -4. And because domain deals with x's, I'm going to put 9 with my x's. Range deals with y, so I'm going to put -4 with my y's. Now, as I follow, two different things you can do. You can start at the bubble and work your way this way and ask yourself what's happening. Or remember, you can also frame that bubble with your arrows. Now, when I look at my x's are going to the left. Left is less than, so it's going to be getting less than 9. It is not going to have the line underneath it because it is an open inequality. My y's are going up. Up on the y's is greater, so my y's are getting greater than. This is also a continuous graph because the lines continue. On problem 15, this one has two bubbles, so I should have two inequalities. I'm going to write my points out very briefly because that helps me. So this is at the point 4, 7. And this is the point -2, 3. So again, domain deals with my x's. My x's are -2 to 4. So my lowest x is -2. At -2, there is an open bubble, so I leave my inequality without the line. X goes in the middle. My highest x is 4, and at 4 there is a closed bubble, so it has a line underneath the inequality. Remember that you can always start your domain and range off with what I've written in the range right here. Put your letter in the middle. You will always have less than signs because we always go least to greatest. Then you just have to remember if any of these need a line under the inequality. Looking at my y's, I have 3 and 7, so my lowest y is 3, my highest is 7, and at 7 I have a filled-in bubble which requires a line under the inequality. This is also a continuous graph even though the line has two stopping points. Because it has a line, it is continuous. Because it has a line, it is continuous. Problem 16 is like problem 14, where we have one point. This point is at -3, 5. Because I only have one point, I will only have one inequality. And -3 goes with x, 5 goes with y. If I frame my arrow with other arrows, My x is going to the right, which means it is getting greater than -3. There's a filled in bubble, so it is also equal to -3. So it could be -3 or it could be anything greater than because it's going to the right. My y's are going down. Because they're going down on the y's, that means less than. And then I have a filled in bubble, so that puts a line under my inequality. Again, because this is a line, it is a continuous graph. Problem 17, because we have a bunch of scattered points, my domain and range are going to have my little squiggly lines to show that they are all separated points. My domain is all of my x values, so I'm going to start left to right just to make sure I can get them all. This x is at -3. This is at -1. This is at 0 on the x's. This is at 2. And this is at 3. For my y's, I'm going to go bottom to top to make sure I don't miss anything. This one is at -2, -1, 0, 1, and 2. This is a discrete graph because my points are all separated. I have separate distinct points. I can tell you my domain is -3, -1, 0, 2, or 3. I have separate distinct points here. On problem 18, we have the same thing with different points, but we have very discrete, discrete points. So I'm going to go ahead and circle that. I can tell that they are discrete because there's no line between them. My domain is -3, -2, -1, 0, 1, and 2. My range, I'm going bottom to top again. And remember, the order does not matter. So if you got these numbers in a different order, you're not wrong. But my range is -1, 0, 1, 2, 3, and 4. And I put the little check marks to remind myself or make sure I catch all of these little points in there. So make sure you know the difference between discrete and continuous. Discrete is distinct, separate points. Continuous is a full line or has part of a line even if it has 2 endpoints. Problem 18, which of the following is not a function? If it is not a function, it means x's repeat. So looking at A, I have 3, 5, and 3. So that one, my x's repeat, which would make it not a function. C, I have 3, 5, and 9. That one is a function, so I'm marking it out because it's asking for not. B, we have 4, 6, and 5. Again, marking it out because it's asking for not. And 7, 8, and 6, that one is a function. So A is the only one that is not a function because those x values of 3 repeat. 19 asks which of the following represents a function, y is a function of x. Remember, we can do the vertical line test. A hits twice, so it's not a function. B hits twice, so it's not a function. C only hits once, so that's probably going to be my answer. D is a super tricky question, but when you draw your vertical line, it hits here, and here, and here, and here, and here, and here, and all these little points. So that one hits a ton of times, so that one is not a function. 20 asks which of these is a function, and this one has multiple answers on the answer choices, so first I'm going to go through my 1 through 4 and determine. We are looking for is a function, so x is no repeats. So I'm looking for where x does not repeat. 1, we have 3, 4, and 3. Nope, x repeats. 3, 4, and 5, that one would be good. 3, 3, 3, no, x repeats. 3, 4, 5, that one would be good. So I'm looking for 2 and 4, which is answer choice B. Problem 21 asks which relation is represented by the mapping shown. So x of 1 goes to 2, 2 maps to 4, and to 6. That's what those arrows mean. So now I'm just looking for an answer choice that matches this, and that would be answer choice D. A would be correct if 1 went to 2 and to 4, but it does not. C is backwards. B would be if 1 went to 4 and 2 went to 2, but it does not. 22 asks which table or mapping or graph does not show this relation. So looking at A, negative 4 goes to 2, 2 goes to 1, 6 goes to negative 3, 5 goes to 2. That one's correct. My guess is going to be it's going to be B or C because I have two mappings here and they're probably not correct. On C, negative 4 goes to 2, 2 goes to negative 1, 6 goes to negative 3, 5 goes to, whoops, that's supposed to be a 2. So it's probably that. Let's double check. 4 goes to 2, 2 goes to negative 1, 6 goes to negative 3, 5 goes to 2. Nope, that one's correct. And then the point negative 4, 2, 2, negative 1, 5, 2, and 6, negative 3. So C is our correct answer. 23 asks which is not a function. Well, A passes through the vertical line, but they are looking for not, so it would not be the answer. B is a function. C, if you notice, C hits twice. So C would not be a function. D only hits once, so it would be a function, which is not my answer. 24 asks which mapping best represents the function y equals x squared minus 3 when the replacement set for x is negative 2, negative 1, 2. So remember, we have to take these three and plug them in. So negative 2 squared minus 3, negative 1 squared minus 3, and positive 2 squared minus 3. First, I need to figure out what my answers are. Negative 2 squared is a positive 4. 4 minus 3 is 1. Negative 1 squared is 1 minus 3 is negative 2. 2 squared is 4 minus 3 is 1. So we are looking for negative 2, 1, negative 1, negative 2, and 2, 1. So first, I'm going to look and see where do I see these in my y's. Well, I don't see it in A. I see it in B. I do not see it in C, and I do not see it in D. So without even checking my arrows, B is probably my correct answer. When I double check, negative 2 and positive 2 both go to 1. So here, these are the y's that I'm looking for. The only place that has those y's in the mapping is answer choice B. Problem 25 asks us to find the range for this. So remember, my domain is my x values. So I'm going to replace x with 1. I'm going to replace x with negative 2. And I'm going to replace x with negative 3. And I can plug these in and find and solve. Also remember, you could plug this into y1 and use your table. I'm going to show you that method just to remind you. So in your graph, on your calculator, we have y equals, we want negative 3x squared, and then plus 4. If we click second graph, it will take us to the table. And we are looking for 1, negative 2, and negative 3. So negative 3 would be negative 23. I started with 3 x's, so I'm looking for 3 y's. Negative 2 would be here when x is negative 2, y is negative 8. And then when x is 1, y is 1. So 1, negative 8, and negative 23 would be my answers. For 26, 27, and 28, they are asking us to use the f of x or the g of x functions. Remember that the letter in front tells you what function you are going to use. So 26, we are looking at function f. So I'm going to rewrite that function. Whatever is inside my parentheses is my x value. So instead of x, I'm writing negative 3 and solving. So I plug in negative 3. Negative 3 squared is positive 9. 9 minus 5 is 4. 27, they want me to use the g of x function. So g of x is negative 4x plus 2. And then remember, they're giving you an x value inside the parentheses of negative 2. So negative 4 times negative 2 is a positive 8. 8 plus 2 is 10. 28, they're asking us to use both forms. So first I'm going to find if I plug in negative 1 in the g of x. Then I'm going to find if I plug in 2 in the f of x and then subtract them. at the very end. So remember, g of x is negative 4x plus 2, so negative 4 times negative 1 plus 2. Negative 4 times negative 1 is a positive 4. 4 plus 2 is 6. In the blue, my f of x function is x squared minus 5. So 2 squared is 4. 4 minus 5 is negative 1. Now, they want me to subtract this, so I have to throw in that extra subtraction sign. 6 minus a negative 1 is the same thing as 6 plus 1. 6 plus 1 is 7. Remember, you can put this into your calculator. If you put all of this into your calculator, that's fine, but make sure you put a minus sign and then add extra parentheses here because you are wanting to subtract 2x squared minus 5, not just 2x. Problems 29 through 32. They are asking us to use f of x, well, I guess 29 through 34, excuse me, to find the following. So 29, f of negative 1, they're saying x is negative 1, what is y? Well, x of negative 1 is here, y is 5. Problem 30 is saying x is negative 2, what is y? When x is negative 2, y is 7. 31, f of negative 1 we just found was 5. F of 2 we just found was 7. Oh, sorry, that's not 2. F of 2 is negative 1. 5 minus negative 1 is a positive 6. So all we're doing here is replacing answers. 32, they're telling me y equals 5. What is x? Well, y equals 5 when x is negative 1. 33, if x is 2, find f of negative 2 plus x. So negative 2 plus 2. So that would be f of 0. When x is 0, y is 3. And then they want us to do 3 times f of 5. When x is 5, y is negative 7. 3 times negative 7 is negative 21. So remember, if it's inside the parentheses, it's x. If it's outside, it's y. If they're giving you x, just go find that x value and look at what goes with it for the y. The last one. A person's height, is this discrete or continuous? Well, a person can grow and you can be 1/4 of an inch, you could be 1/8 of an inch, you could be 1/2 an inch. So we can measure a person's height in a line, so I would say it is continuous. A bag of chips, yes, you can have parts of chips, but you would have like 1 chip, 2 chips, 3 chips, so that would be discrete. The distance from London to Houston would be continuous because you can be 1,165 miles away, or you could take a step closer to Houston and be a tiny bit closer. Temperature is discrete because you have very specific temperature measurements that you can have. And people are also discrete because you do not break up people or put people into parts.